If you don't get it done today, yeah. All right, so we are going to find cosecant, secant, and cotangent. So first off, we need to know what these functions are. I'm just going to move these down. Cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. Okay, so sine of theta, we're going to use theta to represent our angles. Have I used that yet with you guys? No. No? Okay, so this is known as theta. It's a Greek letter. It's the letter that represents an angle measurement most often. So sine of theta is the same as 1 over cosecant of theta. So they're reciprocals of each other. So if you find out what sine of theta is, and you're asking for cosecant, you just have to find the reciprocal of it, and that's your cosecant. Cosine of theta, so cosine of an angle is equal to 1 over secant of theta. And then tangent of theta is 1 over cotangent. Okay. So CSC, this is cosecant. SEC is secant. And COT stands for cotangent. Now the easiest one to remember for what goes with it is tangent and cotangent. Those are probably the easiest two to remember that they go together because they're clearly reciprocals of each other. One is tangent, the other one's cotangent. The way how I remember sine and cosecant go together is they start with different letters. And cosine and secant also start with different letters. So sine's going to go with cosecant because that's our S and C, the two different letters. Cosine would go with secant, C and S, the two different letters. Okay, so that's a pretty easy way to keep them apart. So we're just going to find ratios of these. So what we have to do to find the ratios is we first need to figure out which one it's the reciprocal of and find that value first. So cosecant of A. Cosecant is the reciprocal of sine. So we first want to figure out what sine of A is. So, see, my number disappeared down there. There it is. So sine of A. So here's our angle A. So what side is adjacent, opposite, and hypotenuse?
145 over 9, right? Wait,
we're doing the first problem. That's fine. Which side is adjacent, opposite, and hypotenuse? 13. Okay. 13 is the hypotenuse. 12 is the opposite, and adjacent is 5. Okay, so what would sine of this angle be?
12 over 13.
Yep, so sine would be 12 over 13. So what would cosecant of A be?
13 over 12.
13 over 12. So you just have to figure out what the sine value is and then take the reciprocal of it. Okay, secant is the reciprocal of cosine. So what would the secant of angle A be? Or what would the cosine of angle A be first?
5 over 13.
Yep, 5 over 13. So what would the secant of A have to be then? 13 over 5. Okay, cotangent is the reciprocal of tangent. So what's the tangent of A?
12 over 5.
12 fifths. So that means the cotangent of A is what? 5 twelfths. Is that okay? So far? So then what would we do to find the cosecant, the secant, and the cotangent of B? What would we have to do different from how our triangle is set up right now? For B. Okay, so we're looking at angle B. Our opposite and adjacent are different. So here's our angle B. So which one is opposite now? 5, and adjacent then is 12. Okay, and then we go through and we do the same exact thing. So now sine of b would be what? 5/13, which means cosecant of b would have to be 13/5. Okay, cosine of b would be what? Yep, 12/13, which means secant of b would have to be 13/12. And then tangent of b, tangent of b would have to be what? 5/12, so cotangent of b would have to be 12/5. Is that okay? Pretty straightforward? Okay. You got it, or do we need to do another example of it? You got it? Okay. So then we're going to try to find some exact values. And so we have a total of 6 trig ratios. We have sine, cosine, and tangent. And we also have our cosecant, our secant, and our cotangent. So what we're going to do is we're going to find exact values of the 6 trig functions of theta if the terminal side of theta is in standard position at a given point. That's not on the sheet. Sorry. You probably want to write this down somewhere. The rest of the notes won't be on the sheet. You can just write it on there. So find the exact values of the 6 trigonometric functions of theta if the terminal side of theta is in the standard position at the given point. So there's a few words in there that we need to know. We know what the 6 trig functions are: sine, cosine, tangent, cosecant, secant, and cotangent. Terminal side. The terminal side just stands for where your angle is. Okay? And then standard position means it comes from the origin. All right, so standard position just means that we start at the origin and we go out. So what we want to do first, so if here we have the point -3, 4, the first thing you want to do is just sketch a little graph and think about where the point -3, 4 would be. Which quadrant would -3, 4 end up in?
Second.
In the second, we'd go over 3 and up 4. So that would be like our angle. Okay. So what we're going to do with this is we're going to form a right triangle, and we're just going to drop it straight down to the x-axis. So your theta here is always formed with the x-axis.
Is it always a 90 degree? Like right triangle?
Well, if we want to find the 6 trig ratios, it has to be on a right triangle. Sine, cosine, tangent only work for right triangles. So if that's at our point -3, 4, we should know some lengths of this triangle. So this point up here we know is at -3, 4. So how far to the left did we have to go? -3. And how far up did we have to go? 4. So if we have 2 sides of the triangle, and this is a right triangle, can we find the third? How can we find the third? Yep, a² plus b² equals c². Anyone just know what that is? This is one of your special right triangles. 3, 4, yeah, 3, 4, 5 triangle. So this would have to be 5. That's one of your Pythagorean triples that you should know. Okay, so now what we're going to do is we're going to use this triangle and we're going to write down our 6 trig functions. So we're going to find out what sine of theta is, what cosine of theta is, and what tangent of theta is. And then we will also find out the reciprocals. So we will also find out what cosecant of theta is, secant of theta, and cotangent of theta. Yeah, well I want you guys to get used to this theta symbol because that's what you will be seeing as your angle measurement. So, turn your phone off. So if you want to use a different letter, you can, but you should start getting used to that because that's what you will be seeing for the future. Okay, so looking at here, and where our angle is marked, how would we label our sides as adjacent, opposite, and hypotenuse?
Would you go off that right?
Yeah, you're going to go off your theta, off your angle.
So the hypotenuse is 5.
Yeah, the hypotenuse is 5.
Opposite's 4.
Opposite's 4, and adjacent has to be -3. So we're going to use those values. So sine of theta would have to be what? Yep, 4/5. Which means cosecant of theta would have to be 5/4. Okay, cosine of theta. Yep, -3/5. Which means secant of theta would have to be what? Yep, -5/3. Tangent of theta. While I agree that 4 and 3 are part of it, we have to take care of the negative sign. So you'd say -4/3. And then cotangent of theta would be -3/4. So there are 6 trig ratios for the point -3/4. Yes, we're learning it. It will be on a test and probably on your final. Yeah. Okay. Okay, I was going to say, normally everything I teach you is on a test. All right, number 2, 10, -6. So what should we start off with for here? Start off by doing what?
Drawing it.
Drawing it, okay. So where would 10, -6 be? Which quadrant?
In the third. The third is the fourth.
I don't know, which one is it? Yeah, the 4th. 10, -6. So there's about where 10, -6 would be, so then what should I do from here?
Draw the line.
Draw the line in. And then which way do I make my right triangle?
You go up.
I go up because it's always got to be with the x-axis. So there's my right triangle, and I label my theta over by my x-axis. We go, okay, so now here, 10, -6, so which 2 sides do we know? So what would be this horizontal length? 10. And then the vertical would be -6. And how would I find my hypotenuse? Yep, a squared plus b squared equals c squared. So here we have 10 squared plus a -6 squared is c squared. Well, 10 squared is what? 100. What's -6 squared? So 136 gives you 136. Square root of that. Can we simplify the square root of 136 down? Are there any perfect squares that fit in there? Probably. Well, let's figure out if there are.
Yeah, 4.
4 times what?
34.
Okay. So 136 is 4 times 34, which means what is that simplified down?
2 squared root of 4.
So 2 square root of 34 is our hypotenuse. Okay. So we want to label our 3 sides as opposite, adjacent, and hypotenuse. So which one would go where? Okay, the opposite is -6. Adjacent is 10.
Hypotenuse is 234.
Yep. Hypotenuse is our other one, the 2 square root of 34. So now we're going to find our ratios, and this time we will most likely have to simplify each of them down because those definitely all have some common factors in. So we will find sine of theta, cosecant of theta, cosine of theta, secant of theta, tangent of theta, and cotangent of theta. So we'll start with sine. So what would sine have to be here?
-6 over 234.
Okay, -6 over 2 square root of 34. Now there's quite a few things about this that are that's not simplified. So first off, what can we simplify?
You do like the 2 and
Okay, so the 2 and the negative 6 we could simplify. How would that simplify down?
3 over.
So negative 3 over the square root of 34. Okay, can we have square roots in the denominator, though?
No.
So how do we get rid of that? How do you get rid of a square root?
Square.
We can't square it because we don't have an equation here.
You should tell us.
No, I shouldn't just tell you. I want you to think about how we would do it. Times it by, what would get rid of the square root of 34? Multiplying it by, yeah, multiply it by the square root of 34. If we do that to the denominator, better do it to the numerator. So we have negative 3 times the square root of 34 over, what would our denominator be?
Or just go away. No, it won't.
Clarify that more. What's square root of 34 times square root of 34? 34. So there's our sine of theta. Negative 3 times the square root of 34 over 34. Okay, now cosecant of theta, how is that related to sine? It's the reciprocal. You can take the reciprocal from any one of our steps. Okay?
You just do it from the first one.
We could certainly take it from this first step here, but then we simplified it down to say negative 3 over square root of 34.
From the last one because then that makes a square root.
Exactly. So we don't want to take it from our last step because if we take the reciprocal of this, where does our square root go? In the denominator, and then we have to simplify again. So instead, which step should we probably take the reciprocal of?
The second.
Yeah, probably our second because it's already simplified. The square root's in the denominator, so when we flip it, it goes to the numerator. So what would negative 3 over square root of 34 be, the reciprocal?
Square root of 34.
Yep, negative square root of 34 over 3. So there's our sine and our cosecant. Okay, cosine. What would cosine be?
10 over 2 square root of 34.
10 over 2 square root of 34. Okay, so how are we going to simplify this down first?
By 2, so it'd be 5 square root of this square.
Okay, so we could change it to say 5 over the square root of 34. And then how do we simplify the square root of 34 in the denominator? Multiply by the square root of 34, top and bottom. So what does that end up giving us for a simplified cosecant or cosine? Yep, 5 square root of 34 over 34. So there's our cosine of theta. So secant, which one will we take the reciprocal of?
The second one.
Yep, so we have square root of 34 over 5. We take the reciprocal of our second step. Is everyone okay with that, choosing which one's the smartest one to take the reciprocal of?
Yeah.
Okay. And then how about tangent here?
It'd be negative 6 over 10.
All right, negative 6 over 10.
Which simplifies down to negative 3/5.
Yep, negative 3/5 would be our simplified version. So cotangent would be what?
Negative 5.
Negative 5/3. So there we found our 6 trig ratios. Okay. We're going to talk about one other thing, and then I'm going to let you guys work for probably like a half hour or so, and then we'll come back and do some unit circle stuff. Okay. So the one last thing is going to be sketching angles and finding its reference angle. Oh. There is not a secant, cosecant, or cotangent. You just know that it's the reciprocal. So those buttons are not on calculators. So we're going to sketch angles, and now we've sketched angles, but we're going to add on by saying finding its reference angle. So the reference angle is the angle formed with the x-axis. Okay, so it's the angle formed with the x-axis. Same way how we just drew those triangles in, and we drew the triangles to meet the x-axis, and we marked it with little thetas. We want to figure out what that angle would be with the x-axis. Okay, so 225 degrees. Which quadrant does 225 degrees end up in? the third quadrant. So we'd sketch it. Okay, that's what we did a couple days ago. Okay, and then its reference angle is we want to know what angle it forms with the x-axis. So here, this would be its reference angle. Okay, so how would I be able to figure out what that angle measure is? Our angle here is 225. What's the angle there at the x-axis? 180. So this is 225 degrees. This is 180 degrees. How would I figure out the angle measure in between them? Yeah, just subtract them. So it's 225 minus 180. Yeah, 45 degrees. So our reference angle here is 45 degrees. Okay, so it's just adding a little bit more on to sketching. Okay, 330 degrees. So which quadrant does 330 degrees end up in? In the fourth quadrant. So there's our sketched angle. Now our reference angle will be between that angle measurement and our x. So right here's the reference angle. So how would I find this angle measurement? Yeah, now we would subtract it from 360, because if we go all the way around, that's 360. And that one's at 330, so when we subtract those two, what do we get? 30. So 30 degrees is our reference angle. At 270, so you could go to either side, and it would be 90 either way for your reference angle. Okay. 5 pi over 6. So 5 pi over 6, which quadrant?
In third.
It's in the second quadrant. Okay, so second quadrant. So now your reference angle between that measurement and the x-axis is right there. So this is 5 pi over 6. What angle measurement in radians is down here on our x? Pi. So what's the difference between 5 pi over 6 and pi?
Pi is not over something at the moment.
Okay, so what would you have to do?
Put over one like.
So get like denominators. So if this is 6, what denominator do we need here? 6. And to keep it pi, then what do we put up here? 6. Okay, so what's the difference between 5 pi over 6 and 6 pi over 6? 1 pi over 6. So pi over 6 would be your reference angle.
So how can we put the 6 there? Just
The 6 here? Because if you multiply something by the denominator, you have to multiply it by the numerator. 6 over 6 would reduce down to 1, and we started off with 1 pi.
okay.
All right, we'll do one last one of these. 7 pi over 4. So which quadrant?
It's in fourth.
Yep, it's in the fourth quadrant. So here we are at 7 pi over 4. There's our reference angle, and what measurement would be up at the x-axis then? 2 pi. So we want to know what the difference is between 2 pi and 7 pi over 4. Yeah, we'll want common denominators. So what would be, let's multiply by 4, so it would be 8 pi over 4. So what's the difference between 8 pi over 4 and 7 pi over 4? 1 pi over 4. So your reference angle is pi over 4. Is that okay? All right.
Never get negative, right? You just subtract.
Yeah, you subtract and you